Welcome to the latest installment of Galen Healthcare's free webcast series. Today we're going to be talking about some best practices for HIE participant onboarding. So just a couple of housekeeping items before we get started. So everyone's been automatically muted. If you do have any questions during the presentation, please use the Q&A panel to submit them, and upon conclusion, we'll do our best to answer any. So just for some introductions, my name is Ryan Hunt. I'm a managing consultant here at Galen Healthcare Solutions, and I'm joined today by Evan Lee, who serves as a technical consultant focusing on HIE work. Both of us have been involved with a number of private and public HIEs around the country for the last 4+ years, serving in various roles, including project management, performing net new development, QA, day-to-day maintenance, as well as serving as migration consultants when converting from one HIE platform to another. So today we want to share some of our opinions, experiences, and lessons learned from HIE-related projects. So just looking at the agenda, I'm going to start off with kind of a quick definition of an HIE, types of HIE, so meaning public and private, what value an HIE provides, and really how does that HIE become valuable. So next we're going to talk about understanding your client base, so understanding your sending and receiving systems, as well as some key pieces to keep in mind when integrating with those systems. Next we're going to jump into primary and secondary services that an HIE can offer, talk a little bit about some things to think about regarding maintenance and scalability, and then going over the roles for implementation. And then I'm going to hand it over to Evan to kind of talk about things more at a granular level around, the more technical pieces related to onboarding, including message specifications, common interoperability issues, and then how we've mitigated those issues in the past. And then before we wrap up, do a quick poll of the audience and then field any questions people have submitted during. So first up, whether you're a private or public HIE, the goal really remains the same. It's to facilitate the successful exchange of clinical data to assist in decision-making and improve overall care while lowering the cost. When we're looking at private versus public, there's really 4 main differences. So the first being funding. So, and specifically where the funding comes from. So private HCOs, it's kind of like it sounds, private funding. This is either going to be coming from maybe a large IDN, a group of private hospitals, or maybe a health insurance company. Public, generally it's going to be funding from the government in one form or another. The second difference is geographic reach. So private is usually focused on a specific region or maybe a specific group of facilities, while public is more often than not statewide. The third is kind of funny, but enthusiasm. You're going to have different levels of enthusiasm to participate depending on public or private. So private, the client, the hospitals are really the driving force behind adoption, while public, clients or participants need to be recruited. And the last, scope of services. So private HIEs will usually have smaller short-term goals and really build upon those over time, while public may offer more services and have more farther-reaching goals sooner. Given that they need to really sell to their participants of all different sizes and types in the state. So what value does an HIE provide? So we talked about, the exchange of clinical data, so really the exchange of a consolidated patient record, but also, as you build up these, huge data sets, we're going to have the ability to glean information off of that data set. So to better understand the population which you're serving, as well as the trends happening in that population. And, how does the HIE become valuable? It's really obtaining quality data and then providing different ways to share it. So for the purposes of this webcast, we're really just going to focus on a large public HIE, and I'm going to be going over some of the considerations prior to really go live and adoption, and then Evan's going to be jumping more into the actual implementation phase. So the first thing we want to do is really understand the sending and receiving systems. So what is our client base? If we're, a public HIE, our client base is going to be very broad. We're going to have huge inpatient hospitals in the state. We're going to have ambulatory, which may be, large 300 physician practices, or maybe one provider in a rural area. We're also going to see interest from long-term care or nursing homes, or maybe skilled nursing facilities. It's really valuable to understand our target group before purchasing an HIE application. With that different client base, we're going to encounter a lot of different technical capabilities, whether those participants are on a hosted solution or they have an on-premise solution. If they have, if it's a large inpatient hospital, we may have a 150-person technical team, which is a lot different than dealing with, a one-doctor practice where the IT person is also the office manager. So, public HIEs need to be really flexible in how participants can communicate with a system. So we're going to talk about some of those services later. Another thing we need to understand really before getting into the implementation phase is where ownership lies. This may be one of the biggest hurdles to onboarding. So what this means is, everyone has their own code sets, whether it be Epic, Meditech, or an HIE platform. They're supposed to be standardized, but really, real life, we don't see that. So when one code set doesn't match, who does that fall on? Whose responsibility is that? Kind of who concedes in the end and makes the translation? Are we going to be taking all ownership within the HIE side and really doing a lot of one-off implementations? Or are we going to push that ownership on all the participants? One other consideration, when you're kind of understanding your client base is data filtering. So for sensitive data, so this is most likely lab results, maybe with HIE or mental health, for instance. Are these being filtered out on the sending side, or is it the HIE's job to prevent that type of data from entering the repository? Or can we enter it with specific security settings? It's all different, per state. Also around data filtering, patient consent, we all know the terms opt-in, opt-out. Where is that occurring? Is the HIE still receiving opt-out patients, and do we need to filter them out? Or is the sending system not even including them in the demographic feeds? So, once we understand who our client base is, we're going to want to understand how we're going to facilitate that primary goal of data exchange. How is data shared? So really there's three types of common data sharing, being inbound and bidirectional. So first I want to talk about inbound a little bit. So what this means is, the HIE is receiving inbound feeds from its participants. So we're receiving data, we're becoming a large-scale repository for that clinical data, but really the only way to access it is through the portal. The majority of providers will not break their current workflows to access an HIE portal, even if they can access through a single sign-on solution. Because if you're seeing a patient, there's no way to guarantee that that HIE has data for that patient if you're just logging in without any type of prompt. So, that's taking, time away from the encounter with your patient. So we've seen a lot of difficulty through adoption with just portal access on an inbound HIE. So what we've seen that really helps is bidirectional. So having some type of bidirectional, and there's kind of two flavors. So the more minimal one is alerts or notifications. So it's really a simple way to share critical information about patients. So when different events occur, such as an admit, discharge, or ER visit, and we receive a message from one participant, a notification can be sent out to participating providers via direct secure messaging, otherwise known as DSM, which we'll talk about later. And this will actually prompt users to access the HIE portal. But really, the most valuable type of data exchange with the most adoption is utilizing ITI transactions or IHE protocols. And so these are messaging standards that are built into existing EMR workflows. So most of the big ones, Epic, Meditech, Cerner, they all have these. And so what it is really these transactions will occur behind the scenes as patients are ushered through an encounter. So let me just explain a little bit more about ITI transactions on the next slide. So these are some of the more basic ones. So I just want to give you an idea of kind of what we're working with here. So provide and register. So these are XML-based transactions that contain CCDA. So this will occur at the end of an encounter. So if one hospital is seeing a patient and the end result is, closing that encounter and discharging the patient, transition to care document will be generated and sent over to the HIE. Patient identity feed, this is either a HL7 version 2 or an XML-based transaction, which will perform registration or query the MPI. So this is helpful in understanding if the patient exists in the HIE. So, when the patient is admitted into the particular facility, a query will go out to find that eMPI from the HIE. If one's found, it will come back and notify the staff that, that patient does indeed exist in the HIE. Query registry or ad hoc query, these are XML-based transactions that query for available documents. So if we do find that the patient has an eMPI, then it's going to go and grab whatever transitions to care or discharge summaries that exist in the HIE. And lastly, retrieve document. So we find that the query registry response has metadata around, date, facility, and type of document that the HIE has. We can choose to retrieve those documents and pull those into context during the patient's visit. So we have, three ways of facilitating that primary data exchange, kind of that main goal of the HIE. But with public HIEs, you're, going to see a lot of secondary services being offered to kind of drum up enthusiasm, I guess, to use that word again. So some secondary services that we see offered quite a bit are DSM. So we mentioned this before, direct secure messaging through an accredited HISP, which is a health information service provider. We'll also see communication kind of brokered through the HIE with state or federal agencies. So, for example, CDC with syndromic surveillance, DPH with ELR or electronic laboratory reporting, as well as state immunization registries, and then eHealth Exchange or the Sequoia Project, which will promote communication with other HIEs as well as the DoD and the VA. And lastly, vendor pipes. So, this is very good for smaller practices. So instead of, a smaller practice maintaining their own inbound interface from a vendor, let's call them like LabCorp or Quest, we can have one pipe feeding through to the HIE and populate lab results, which will end up saving money down the line for that practice. So to recap, we have our services defined. We have our client base. Really, before we even start implementing, we want to start planning ahead for increasing volume. So, a lot of HIEs don't anticipate the amount of data that actually comes out of one facility. and not even one facility, but maybe compound that by 10 times over when you have 10 different hospitals connected. You know, tens of thousands of messages per hour, maybe even millions per day. So it's very important to plan ahead for that increasing volume, making sure you have enough memory and enough space on your system. Also, understanding throughput for your mission-critical applications. We've seen issues come up with EMPI services or document repositories or document registries where they really can't handle the amount of throughput that's coming through on a daily basis. And lastly, data pruning. You know, do we have a process that exists to prune data? So really, how do we keep the data that we're receiving clean and relevant? And so we have a plan, and we're ready to move forward. You know, what roles do you need for a successful implementation now that you've established ownership and offerings? So here are just some important roles that we found to be necessary for success. Recruitment. So again, we're dealing with a public HIE. We really need to help participants realize the value of the HIE and contract them. Network resource to help establish methods of secure communication. Implementation consultant or interface analyst. So we want this on the participant side as well as the HIE side to build the interface. I skipped over that one. Clinical contact for validation. You know, if we get massive amounts of data from someone, it won't provide value if it's incorrect. So we need to work with the participants to, you know, verify that the data looks the same on the HIE backend as well as where it came from the source system. Project manager is essential to keep everyone on task. And a trainer, so two trainers really. You know, for the HIE side, we want a trainer to almost train the trainer, so to train the client on how to use the HIE, and then we want the client's trainer to really teach those providers how to utilize the HIE effectively. So that's kind of the high-level things to think about, you know, before you go down the path of trying to implement an HIE. So now I'm going to hand it over to Evan to go over some of the detailed topics around basic technical challenges our implementation teams have encountered.
Thanks, Ryan. So I'm going to be talking about some of the more granular pieces of preparing to develop an interface. Also going to be talking about some of the issues an analyst might encounter when you're going through the process of actually building one. So first things first, you want to leverage established standards when you're building interfaces. Regardless of whether you're processing HL7 messages or CCDs, interfaces you build will be based usually on a set of standards that make sharing across organizations uniform and straightforward. So CCDs are based on IHE standards, including the use of PICs and XDSD. HL7 messages are based on HL7 standards. Becoming familiar with these specs will go a long way in giving you some perspective of what to be looking for when you're building or troubleshooting interfaces. We'll be posting this PowerPoint to our wiki after the presentation, so please feel free to refer to these links to access HL7 and IHE standards after the presentation. A Chihuahua and a Great Dane share 99.8% of the same DNA, but it's that 0.2% that make them wildly different when it comes to how they look, how they behave, their susceptibilities, and their strengths. Interfaces are a lot like dog DNA. Most things you see about every like-type interface is going to be exactly the same, but as an analyst, it's your job to find those pieces of the DNA that make each dog different. So before we delve into the specifics of each of those gotchas, one piece of advice is to leverage previous implementations. Excuse me. Let's say, for example, you dealt with an interface, an ADT interface from a particular EHR vendor 6 months ago, and now your HIE is looking to do the same for a new facility that uses that same EHR vendor. Instead of starting from scratch, it can be a huge time saver to copy that interface and then just remove all the logic that's specific to the previous clinic. While it won't necessarily be a one-to-one plug-and-play because of the differences in vendor version or configuration specifics related to that participant, it's a whole lot better than having to build a complete interface from scratch. In addition to the interface itself, as an analyst, you'll want to keep detailed notes on the specific areas of each EHR vendor that might cause snags. An analyst may build many interfaces before dealing with the same one again. So keeping notes about how to resolve issues will help big time when you have to revisit those same issues. Also, keep a toolbox of solutions. Saving JavaScript or SQL logic that has been used in the past to solve frequent and common problems can be a great tool. Before long, your HIE will have a toolkit for building interfaces from each EHR vendor and will have logic for quickly resolving issues that occur over and over again. Once you have an understanding of the standards around the message type you'll be receiving, as an HIE, one of the first things you'll want to do in addition to exchanging connectivity information is sending out and having your connecting participants fill out documents called code set documents. Code sets are sets of accepted codes for certain fields within an HL7 message that accept only certain values. So in this example right here, on the top right, we have a message example where the participant is sending FM in a PID 8 HL7 field, that's the gender field, and they're sending WH in PID 10, which is the race field. As you can see from the code set document on the left, the interface engine value accepts different values for female and a race of white, respectively. Collecting mapping discrepancies via a code set document before kicking off interface development can significantly decrease the amount of time required going back and forth reconciling code differences to build an interface. As an HIE, you want to work with your interface engine vendor to create a document that includes all the fields that are based on a coding system and aren't free text. Then the participant can quickly and easily fill out this code set document and return it based on their specifications. Once you have a complete code set document, you can begin mapping the values participants will be sending that are expected and accepted by your HIE. So in this case, the value FM will get mapped to F because the participant is sending FM from the data source, and the accepted value for that equivalent meaning is F on the HIE side. And same thing for the race. So they're sending WH for white, but as you can see, the HIE is expecting 2106-3 for white. So what sort of data is being sent? When you're building an interface, it's important to understand what type of information the participant's going to be sending across. For example, if you're building an HL7 ORU result interface, is it an interface for just one type of result like labs? Or is it an interface that will be handling labs, radiology results, and transcriptions? Based on what you're receiving, the configuration and the complexity of your interface is going to change drastically. How these interfaces are built will depend on several variables like cost structure, how similar interfaces have been built in the past, potential bottlenecking, etc. Even more granular, if the participant is sending labs, will there be multiple types of labs? For example, will the participant send microbiology, pathology, or blood bank information, which can be structured differently and will require a little bit of extra attention to make sure it's all configured correctly. Asking the participants these questions prior to implementing the interface can help you as an analyst understand what sets of messages you'll need to test or what challenges you may encounter during build and testing. What fields will be populated in the message? Depending on the interface engine vendor a particular HIE is working with, the version they're working with, and how that particular HIE has chosen to configure their system, some fields will be required in an HL7 message or CCD message, and most won't. It's important to ensure that fields that are required are always being populated. If a required field is missing from an HL7 message, and those messages fail due to that missing field, then pieces of vital health information will be missing from the patient's HIE record, which may result in patient safety issues. As you can see here, here's a message definition from one of the interface engines that we work with a lot. And this R right here indicates that a field is required. So you can see here in this HL7 MSH segment, there are several fields here that have been marked as required. And depending on which interface engine that you're working with, this may be formatted in a different way, but typically there are fields that will be required. So what optional fields will be provided? In a given message, whether it's HL7 or CCD, some participants provide more information and some participants provide less. That'll depend on the EHR vendor they're using and how their system's configured. it's important to understand from the very start of an implementation what HL7 segments or HL7 fields or CCD sections a participant will be sending and what values they could send in those fields and test appropriately. Not all HL7 fields are required, and not all CCD sections are required. Some optional fields may be ignored, and others may be processed if they're present. One example is a PID segment demographics field like race or ethnicity. They aren't required for most interface engines, but they can be used to help build a stronger patient identity in the EMPI. And if participants are sending them, and you as an HIE plan on processing them, it's important you understand what values could be sent. And that's where the code set document we discussed earlier comes into play. How will the data be used? So when an HIE is receiving data, it's important to step back and look at the bigger picture of how the data will be used. Is the data just going to be used to populate the clinical portal using XML structuring and style sheet, or will the data actually be used in analytics and big data efforts? If the data will be used in analytics and population health efforts, discrete parsing and data normalization becomes more important, as you want each piece of data broken into the appropriate fields if you're going to be gathering and conducting analysis on large sets of data across large populations. Some fields in HL7 or CCD messages should have a one-to-one relationship between the code and the description in a given field. For example, the attending provider code here, white, should only be used for one provider. But as you can see in our sample, it's used for two providers, Tony White and Samantha White. This may seem fine, but when certain interface engines initially consume a provider code, the provider code gets associated with provider name information that gets loaded first. So let's say Tony White's the attending provider on HL7 message. When that message gets loaded, the database is populated with a code of White, and then it's associated with the first name and last name that's included in that message as well. And then when the next message with the same code, White, is loaded, but this one's actually for Samantha White, the system doesn't look at the first name, last name. It just looks in the database to see whether it has a code of White. Because it does have a code of White, it's going to pull back Tony White because Tony White was loaded first. We run into situations where participants didn't have the capability to change this provider code, and in instances like this, you may have to use some sort of combination of first name and last name to create a unique code. So you can see over here on our right, I've combined the first four of the last name with the first four of the first name to create a unique code. So now when Tony White provider information is sent in, this will get recognized as a unique provider, and the same for Samantha. The same situation can come into play for order and result codes and descriptions. As an analyst, you'll want to identify instances where the same code may be used for more than one lab. In this example, the code PT is used for two different results. Whichever result is loaded first with that PT code is what will display whenever the code PT is used, regardless of what the description is. So let's say prothrombin time is loaded first with the code of PT, but then a physical therapy lab comes in right after that. That physical therapy lab will display as prothrombin time because it was loaded with the code PT first. So it's first come, first serve. Whatever description is loaded with this PT code first, that's what's going to display every time PT comes in. To resolve this, an analyst will have to create a unique code for each result. By combining the PT code with the description of the result, you can create a one-to-one relationship between the result code and the result description. So instead of the code being PT for each of the results, you would want each code to be PT underscore and then the name of whatever the result was or test was. So PT underscore prothrombin time will now be unique to prothrombin time, and similarly for physical therapy. Another issue I've seen happen is that some fields that are designed to be unique, they are not unique. If a unique message ID, that's MSH10, if that field is not unique, you can run into an issue where an interface engine recognizes a message as already having been received. That'll result in a duplicate message error, and the second message received with that same message ID will fail as the system accepts only one message with a given message ID. In this example above, we have two different MSH segments here from an HL7 message. One's from June 3rd at 9:27 in the morning, and one's from June 3rd at 7:27 in the evening. But as you can see over here, they have the same message control ID, MSH10. In this case, the one that comes in second, the one from 7:27 p.m., is going to fail because a message has already been loaded with this message control ID into the database. So you'll want to make sure that all MSH10 values for your messages are unique. And this is where I find the tool HL7 Spy really handy. So when you're using the tool HL7 Spy, you can quickly analyze hundreds or even thousands of messages to ensure that there aren't any duplicate values in the fields that are supposed to be unique. So the first thing you want to do is communicate to and verify with the participant that those fields are unique. But once you've gotten verbal confirmation that that's the case with them, you'll want to see it for yourself. So once you have a test feed from your participant and you've received a couple thousand sample messages or so, you can go ahead and download those sample files and open them inside of HL7 Spy. HL7 Spy allows you to quickly and easily verify that those fields are unique by getting statistics for that field for all your messages. In the example above, I've returned the field statistics for 5,106 ADT messages. As you can see, out of 5,106 messages, there are also 5,106 unique values. So that indicates that each value is unique. And that's a good sign because 5,000 is a pretty good sample size, and you have a pretty good idea that likely those numbers are unique at that point. Similarly, if you have multiple labs that have the same order number, you can run into issues where two different labs merge or update one another. So there are a few different fields that you'll want to make sure are unique, and another one of those is the encounter number, which is in PD119. So field length limitations. Most interface engines or receiving systems have limitations to how long various fields can be. This can cause issues when participants are sending values that are longer than the maximum allowed value in those fields. For example, one interface engine I've worked with has a maximum value of 50 characters on their allergy reaction. Depending on the clinic's EHR, the allergy reactions provided may be longer than 50 characters. This prevents an interesting problem as allergy reactions are critical pieces of information that providers need to see. But if a reaction is longer than 50 characters, the message will fail and the information won't populate the clinical portal. The first thing we want to do in this situation is contact the participant and see if there's any way they can provide the same information in a length that actually meets the specification of the receiving system, /HIE. If it's just not possible, another potential solution is to truncate the maximum allowed characters on this field to 50 characters. In the example above, we've truncated the reaction to 50 characters, so the message can successfully populate the portal. One thing I want to point out, though, is that this can potentially cause issues in cases where the text after 50 characters offers significant clinical value. So you'll see that the first few words in this allergy reaction description are dry mouth, and that's pretty much the most important part of the description. But in some cases, that'll be at the end of the string, and you'll be truncating off that important piece. Another potential solution would be to replace any text that's over 50 characters with some sort of indicator to the portal user that more information may be available upon contacting the clinic. So instead of displaying the reaction text, you'd want to display something like reaction too long, contact the clinic. Yet another option would be to not populate the portal with AL1 segments from this particular participant, since the format therein could cause clinical risk and it doesn't meet the HIE specifications. One final potential option would be to work with your interface vendor to actually modify the specifications of the HIE. Some interface engines have configurability around how long those fields can be. It may make sense to increase the maximum length of the field to enable the messages to pass. Regardless of the solution you choose, though, an analyst must be sure that the participant accepts the clinical risk that may be present and have signed off as acknowledging the decision point. It's important to test sufficiently enough to anticipate these scenarios in order to properly manage them. As mentioned, in some cases, HIEs need to make tough decisions around how to resolve these issues, as sometimes there just aren't clean and clear answers. Having a good understanding of an HIE specifications can make a huge difference in skillfully identifying these problem fields before they cause problems in a production environment. Invalid special characters. Some interface engines have difficulty consuming special characters. Depending on how your interface works, messages that contain these special characters may error and not make it into the clinical portal without addressing how to handle each situation. Again, by testing sufficiently with high volumes of messages and by verifying with the participant early whether or not they may be sending characters like this in their messages, you can work to decrease the risk associated with those system limitations. During one implementation I worked on recently, if we encountered the special character of a degree sign, we would get permission from the participant that it was acceptable to replace the sign with the word degree. Similarly, if we encountered a letter with an umlaut or an enye over it, we would replace that character with a normal character without the extra punctuation. The user could discern the meaning of the word or character without losing clinical value. Make sure you've tested these special character cases and how they interact with your system, and make sure you get buy-in and sign-off from the participant that these changes are acceptable. Since we don't have a ton of time, I wanted to provide you guys a list of other potential problem areas when building an interface that I'll just hit at a high level. Ryan already talked a little bit about sensitive labs, so I'm not going to go into it deeply, but it's important as an HIE to have the conversation around how sensitive data will be managed in terms of identifying which labs are sensitive, in terms of granting access to users who should have access to those labs, and also creating a process around how to prevent that information from going outbound when it's not supposed to. Invalid values. As we already hit on in regard to code sets, certain HL7 fields only accept certain values. In our earlier example, we were looking at the field PID 8, which was gender. The HIE only accepted M for male, S for female, U for unknown, and O for other. So what happens if a participant sends another value like R? Will we automatically map that to U to indicate that we don't know what it is? Or will we let that message fail due to being an invalid value? There are advantages to both approaches, so as an organization, you're going to have to choose what makes the most sense for you. The advantage of mapping anything not recognized to U or unknown is that the messages that otherwise would fail, they can pass successfully. So if we receive an R for gender, we map that to U for unknown. The disadvantage, though, is that you have less clarity into what invalid values participants may be sending, as those messages will pass without error as they're being mapped to an accepted value. If you don't map to a default value and you just let the messages error, the messages will have that gender value of R and they'll stay as R, and the messages will error and they won't make it into the clinical portal or the HIE database. So there will be missing patient information from the portal, but in terms of, you will at least be notified that messages are attempting to be processed with values that aren't recognized. And at that point, you can reach out to the participant and reconcile this invalid value. Event types and message order. Message order can be important for some interface engines. Some systems require a logical order of events on certain HL7 messages. For example, an admit ADT message must be received prior to a discharge ADT message with the interface engine I was working on most recently. You want to verify that messages are coming in a logical order and that the interface engine can handle the logical order they're coming in. Result statuses. Some systems have limitations to how documents can change statuses. Off to the right here, you'll see a list of result statuses for a lab. So let's say a lab result comes in with a result status of F, indicating that it's a final lab. But then we'll receive a message for that same result that's in a status of P, which stands for preliminary. Because the lab is already in a final status, it cannot be updated by a message with a result status of preliminary because the final result has already been loaded. The same result has already been loaded with the status of final. You want to be aware of the requirements around result statuses when loading results into your system. Some HIEs advise not to deal with certain result statuses to avoid some of the complexity around this that can occur. Building a test plan. Before you begin testing, you really want to have an idea of the potential pitfalls that could trip your interface up. An optimal test plan will consist of a checklist of all the possible scenarios that might happen when an interface is running. What could possibly be sent, and can the interface properly handle each situation? Fringe cases matter. I know I've said this a couple times, but a good test plan will test each scenario to ensure successful processing. Working with high volumes of messages helps an analyst ensure they're getting a good sample size of the data in order to capture all potential issues. Issue tracking. Oftentimes, an interface analyst will be building multiple interfaces, so it's really easy for issues to get lost or to forget what the most recent status is on an issue. There's also a possibility that more than one analyst is working on an interface, so it's important to keep a detailed and up-to-date log of issues and interfaces dealing with throughout testing. As these issues progress, detailing why decisions are made and specifics around how issues are resolved helps analysts gain perspective on their interface builds. Also, because analysts are sometimes consultants or may not work for an HIE forever, or because an internal employee may leave an organization, keeping good records allows for a more seamless transition if perhaps someone else needs to take responsibility for an interface. Using live data is better. Test data is often too clean and too good to be true. There are certain situations that can happen with live data that just can't happen with test data. And since you're going to be dealing with live data in the production environment, that is really what you want to prove it works. In certain situations, an organization will refuse to use live data or they won't have the capability of using live data. And in those instances, you really are forced to work with the test data. If you have the option, though, I strongly recommend working with live data, as it's more representative of what will be consumed in production, and it ensures you won't be surprised between differences in test data and live data when you finally go live. When you finish testing and validation with the participant, you'll be ready to migrate your interface to production. The process for migration will vary depending on the interface engine you're dealing with and who is maintaining the production environment. But once your interface has been migrated, it may make sense to run through small volumes of messages prior to opening the floodgates to verify the interface is working as designed in production. Oftentimes, small pieces of a configuration can be left out, or there is a small difference between test environments and production environments. Validating and monitoring the first several messages can help you avoid having to resend and reprocess thousands of messages. A go-live checklist. When you go live, there will be a number of pieces you'll want to make sure are happening prior to getting sign-off. You'll want to make sure information is populating the clinical portal successfully. If you're testing CCDs, you want to make sure that your facility can load CCDs in addition to other facilities being able to pull back your CCDs via IPI transactions. The Go Live checklist will help you stay organized when it comes to verifying everything is in solid working condition. You'll also want to monitor the feed and the error queue to make sure every message is passing. If there are errors in that first few hours that you're running your interface, for the first few days that you're running for your interface, it's important to uncover the cause early and handle it as necessary instead of letting it go unresolved and continue to exist in production. Configure your alerts. You may be able to configure alerts so that if a connection goes down or if errors suddenly start occurring, you'll be notified so issues can be resolved with minimal downtime. Different interface engines have different alert notification functionality, but emails can be sent or alerts can pop up in the management portion of the engine. And finally, you'll want to receive sign-off. Once you've monitored the feeds for a good amount of time, you've gone through your Go Live checklist, you've had the participant confirm everything is looking good in the portal, and from their end, you're ready to close things out. Your organization should work to develop a sign-off sheet that indicates the participant and the HIE agree information going to the portal is correct, complete, and flowing. Any other details in regards to the connection that are pertinent should also be included. This serves as proof that the interface was built thoroughly and with buy-in from all stakeholders should there be any questions going forward. As we mentioned earlier, it's key to leverage past implementations. Taking the time to document the lessons learned from previous builds can lead to faster learning. If you don't keep a record of problem areas, analysts are likely to forget critical decision areas and repeat suboptimal practices with the next interface. This is magnified when multiple resources are building interfaces in different ways. Creating a repository and a process for learning from mistakes sets your organization up for success in terms of being able to learn quickly and build consistently. An HIE creates value through its ability to share with others. In order to promote the use of an HIE, it's important to assess how an HIE can maximize the value they provide to their participants. By involving participants in the feedback loop and asking them questions about how the process went for them and how they might improve the system, you can gain crucial insights into the other side of the business that may be harder to see. Always be looking for ways to improve. What's working? What could be better? Continue leveraging practices that are yielding positive results and continually reassess areas where issues are cropping up most frequently. And also continually repeat that process indefinitely as your system improves. Here are some helpful development tools that I use in validating interfaces, and also my colleagues use them. HL7 Spy is awesome for analyzing HL7 messages. You can validate field lengths. You can look at field values, get statistics back on them, as I showed you in a screenshot earlier, and I'll jump into the program later. You can validate that fields are unique. You can anonymize data that is protected health information, so you can share it or use it in testing. You can analyze large sets of data easily, and two of the cooler features are that you can instantly push data natively from HL7 Spy over TCP/IP or TCP/IP connection. And you can also, they've created a sort of HL7 SQL where you can search various fields using a SQL type language. Another great tool is Notepad++. It's a text editor, but it has a little bit more functionality around it, and there are all sorts of plugins that can enhance how it works. Some of the things I like it most for are reading XML documents. You can customize how different file types look, and so they're easy to read. And also, there's a plugin that automatically indents XML documents based on their tags, and it makes reading XML documents much easier. And another great tool is difference checking. So if you wanted to compare two messages and how they differ to see whether they were, maybe there's a long message and they're slightly different, but you can't really tell exactly what's different about them, you can just paste them both in there and click check differences, and it'll show you the differences. Another tool is SOAP UI, which you can test web services with. So in terms of CCDs and the ITI transactions, if you wanted to mimic that in a test environment, you can just paste in the WSDL to the WSDL address into the program, and it will give you the format of that web service, and you can just fill in the information and use it just like the web service would in your test or production environment of your interface engine. And lastly, HL7 Analyst is a free program, and it's very lightweight. And all it really does is you take an HL7 message and you can copy it and paste it right in there, and it'll show you what each HL7 field is in terms of what that field means, and then it'll show you what the values are actually inside of your HL7 message. So that's super helpful in terms of learning HL7 and becoming familiar with the field.